get into reviewing for the code challenge. I'm just going to start a bit of a baseline. Some of this will be like intuitive to you guys, but some of you guys still need a refresher on it. So how this lab review is going to work is we're just going to start really fundamental basics, work our way up from regular old array enumerables, and then talking about object-oriented Ruby, and then relations, and then the aggregate methods. Uzo asked this question earlier, can we leave and come as we please? You can. Just note that we're going to get to the hard stuff kind of near the end, so it might be beneficial to stay the whole time, but if you have to step out or if you want to step out, I understand that as well. Okay, so before we jump into reviewing for the code challenge, I just want to take a little bit of time to talk about enumerables. For example, the popular enumerables are going to be your things like the map and select and find. I am just going to go down the line and ask you guys to kind of participate, starting with Uzo. Uzo, in your own words, without using the word map, what does the .mat method do? Mm-hmm. I like that explanation a lot. Uzo, I think you basically hit the nail on the head. But something else I want to go into more detail, maybe this will help people remember, is just thinking about what .map is in the real world. So T, I'm going to go to you next. I want you to describe in your own words, what is a map in non-coding terms? Like if someone on the street asked you like to explain a map. A layout of the land, yeah. Anything in addition? More details of a map? Sure. I like both of those points. So the first thing you said, T, was like it's a layout of the land, like the real land. The land that we live on is like a three-dimensional globe. And if we use a map, we can show it and lay out in like a two-dimensional spot. And you said on the map, you can find specific places. I like that explanation a lot. And I'm literally just going to go to Google Maps. So this is just a map. And I can type like Flatiron School, DC. So what a map is essentially, just in regular layman's terms, is it is attempting to take this three-dimensional world and transform it to like a two-dimensional like piece of paper or a two-dimensional like screen. To what T said about like, hey, there's specific things on this map. So if you think of the real world, there's a specific Flatiron School DC campus that has been mapped to our two-dimensional screen. So when it comes to map, it's a one-to-one relationship of the real world. You know, if there's one Flatiron School DC, there's going to be one Flatiron DC on the map. If there's one New York, New York, there's going to be one New York, New York on a map. If you have a map with two New York, New York, that's a terrible map. It's a lie, if anything. So one way you can think of a map is you're taking something and you're transforming it to be something else. Let's now take an example of really, really like simple stuff. Let's say I have some strings. I have Anna, I have Anne, and I have Chine. And let's puts all them out. Puts out Anna, puts out Anne, and puts out Chine. And let's say dot length. Let's say dot length. Let's say dot length. And Michael, when I run this, what would you expect to show up in our terminal? So what would that be? Mm-hmm. Okay, let's run that. And sure enough, what Michael predicted was correct. So we get 4, 3, and 5. So this dot length, it is a method that we can call off of a string. You can use, dot length on other things, like you can call it off of an array, but you can't call it off, say, like a number. So Dot length is a method for all strings. Now, what we can do is we can say, let's have an array of Anna, Anne, and Chine. And we are going to say array.map. Do end. You can add the curlies, but do end, it works just as well. So .map is a method you can call off of an array. And the syntax to get this to work is you're going to want some pipes and a variable in between them. Let's call this variable name. So the thing we put into here is how do you want to transform this array into something else? Just like we transformed the 3D globe that is Earth, how do you transform it to a two-dimensional map? We can say, I'm going to put name.length. And when I run this, feel free for anyone to shout this out. What do you guys expect to be printed out? 435 in an array. So thank you, Deja. That is exactly what we got. Now, seems fine. What if I change this and I say 1? What's going to happen now when I run this code? It'll be an error. It'll get Anne. What else do you guys think? That's a possibility. And remember, now that we're in an intimate setting, I'm going to ask you guys questions, and it's okay to say I don't know. In fact, if you say I don't know, that's only going to help you, because then we're going to spend more time on the topic, and I get to actually make sure you understand it. So. It's not inside an array. Anyone else like not know or have any guesses? Error? Okay, let's try this out. I'm going to run this, and it's all ones in an array. So let's think about mapping means a one-to-one mapping. So if I have the campus of Flatiron, I'm going to map that to my 2D piece of paper and call it a map. If I have, my house, I'm going to map that to whatever. What I'm doing here is I have a bunch of names, Anna, Anne, and Chine, and I'm mapping all of them to be the number 1. So the thing we put in here, I can say, it's a wonderful time of the year. What's going to happen now? It's going to have 3 times in an array. So when you guys have a dot map, don't think of this as pattern matching, name.length. It's going to always, give me, it's just going to know what happens. What Ruby is doing is it's saying, okay, I'm going to iterate through this array. And for every name, I'm going to run this block. And whatever this block evaluates to be, that's what I'm going to put in my new array that is a one-to-one mapping. So if you did it with a hash, let's do this. What happens if I run this line of code? It'll be an array of 3 empty hashes, because when we say .map, we're saying, for this one, I want you to map it to be this. Or, what's up, Michael? So .map, we're not going to worry about mapping over hashes, because that's not really a useful tool that you would want to do often. You can have it work, but regardless, mapping is a one-to-one. If you map through a hash, you're still going to map every one-to-one key value pair to be something else. What if I do name dot upcase? What's going to happen now? What happened to my code? Okay. What do you guys think? Let's see. It'll be an array of all capital letters. So some things to keep in mind. Map is always going to return a new array. And it's always going to be the same length as the original array. If I have 3 things, if I want to map it, that means it's a one-to-one mapping. I'm going to map it to 3 other things. Which is why, if I say, all right, if I put in a 4, if I run this, I'm going to map each and every name to be the number 4. So the thing we put in is always some sort of transformation. Like, how are you going to transform this 3D globe into a 2D globe? How are you going to transform this string to be something else? Oh, I've just transformed the string to always be the number 4. Okay, so that is .map in a nutshell for y'all. Ooh, yeah, let's talk about this, .collect. So I like to think of the analogy of like, hey, if you're gonna map something, it's a one-to-one mapping, you're representing the 3D world as a 2D thing. You're representing this array of strings as something else, you're transforming it in some way. Let's say .collect, like let's say, apparently like I have one guy, he works at the census, and he's always coming to my house and trying to collect information from me. So if I have this person, he's saying, you know, hey, I'm gonna go to all these homes and collect the income of these homes. What that means is like I'm iterating through every home, but I don't care about the home itself. I'm just collecting the income in the same way, like, you know, when you think of like, what does collect mean in the real world? Someone who collects stamps, or, you know, I only collect stamps, I don't collect coins. So what we're saying is, of all of these strings, I'm going to collect from them whatever they are uppercased. So it depends on how you want to think about it. Now, even though I've changed the name to be .collect, it's going to work the exact same as .map. So what's going to happen when I hit run right now? Let's see. So what would happen if I said .map? What would this do? Okay, so we know with .map, it'll return an array of ones. If I say .collect, let's run this. It does the same thing, an array of ones. .map and .collect are the same exact method, just 2 different names. They're both transformers. It's just, how do you want to think about it? Do you want to think about it as, oh, I'm going door to door and I'm collecting everyone's first name for a survey? Or do you want to think about it, oh, you know, I have all this information and I want to map it or transform it to be something else? Okay. On a scale of 1 to 5, how are you guys feeling about your understanding of map and collect? 3, 5, 4, okay. Michael T, I didn't see that from you guys. 5, okay. Junior, your screen is off, so I have no idea. Okay, let's now talk about the other one. Let's do find all. So, Sebastian, in your own words, without using the word find all, how would you describe what this enumerator does?
It's going to go through a set of data,
Mm-hmm.
and it's going to retrieve everything that matches a certain condition.
Everything that matches a certain condition. Okay, so I like that a lot. Deja, I'm going to ask you, like, outside of coding, if someone asks you to find all, like, what does that mean? Mm-hmm. Exactly. So if someone says like, hey, you know, Deja, can you look around the house and, you know, find all the shoes? That would mean you wouldn't stop until you had somehow convinced yourself that you found all the shoes. So let's talk about this as an enumerable. We'll walk through some examples first. Let's say something like puts and and I'm going to, actually, let's put Anna and puts Chine. And I'm going to say dot length equals 3. Dot length equals 3. Dot length equals 3. Okay, Junior, if this is all I'm writing, we're not talking about the find all enumerable yet, but if I just print out these 3 statements, what would you expect the terminal to show at the end? Junior? Yeah, okay, cool. Mm-hmm. It's all good. Just never know if you're there because your face cam's off.
Yeah, so it would say like for the first one it would say false,
Mm-hmm.
and the second it would say true because it's three.
Yep.
The last one it would say false. I believe.
Okay, let's try it out. So our guess is that it's going to be false, true, false. If I run this, I look at my terminal, I get exactly that. False, true, false. So now let's put this in the context of a dot find all. So let's say I have an array. It's equal to Anna, Anne, Chine. And I'm going to say array dot find all. Very similar to dot map syntactically. And the variable I create in between the pipes is going to represent each individual one of these elements. So if I say name, now what goes in here, Sebastian had said, how it works is you give it some condition. Well, I'm going to give it a condition of name.length equals 3. So as a group, what do you guys think will output when I hit run? Will it be and the string or and an array? Let's see. It's an array of just and. So you guys hit the nail on the head. So select, just like .map, will always return a new array. Even if there's one thing in there, it's still an array. What if I do name.length equals 10? What's going to get returned now? Okay, when we say nothing, does that mean nil? Does that mean an empty string? Let's see. It's an empty array. So how find all, which by the way is also select, works is it'll always return a new array. And if we think of find all and select in the real world, you might have a deck of cards. So a deck of cards, and you're find all of the spades. What you're going to do is you're going to go through every deck of card. You're going to look at the first one oh, this is a diamond. I don't want to keep that. The next one, oh, it's a heart. I don't want to keep it. The next one, oh, it's a spade. I do want to keep that. Let's say you go through a whole deck of cards and you couldn't find any spades. Well, at the end, you have nothing, but your select is still always going to return some array. So let's do this. Let's do a dot find all or a dot select. I'm going to do something different. So dot length is a method you can use off of a string, but there's all sorts of methods you can use off a string. For example, you can use dot include. This is a method. Include and let's copy and paste this. Include and. I'm going to comment this out and run it for y'all. This isn't a method you see a lot, so I just wanted to show you guys how it works. So true, true, false. What we can conclude is if the string Anna includes the string Anne, it'll be a true. If the string Anne includes the string Anne, it'll be true. Does the string Chine include the string Anne? No, that's why we get a false. So if we rewrite this dot find all and we say name dot includes Anne, what would you expect the dot find all array to return? I'm going to go back to Uzo. Let's double check that. Whoops, local variable array not found. That's because that was my bad. I commented the array out. Include, it needs to be no S. But that's exactly it. We get an array of just Anna and Anne. So what if we change this array from a find all to a select? Michael, what's going to happen now? Oh, you're muted, Michael.
If you change it to a select, it would probably do the same thing. Find all and select are the same.
Let's see. Does it do the same thing? It does exactly that. So same exact thing, dot select and dot find all, completely the same code, same logic and everything. Now, what's up? Dot include is different. Dot include question mark is a method we can call off of a string to see if another string is included inside of it. Exactly. So this is just to demonstrate how include works. So what does this line evaluate to be? It evaluates to be the Boolean true. What does this line evaluate to be? It evaluates to be the Boolean true. Let's see if I say one dot, let's put one dot include like so. Let's see if it includes one. I always do that. Let's see. So undefined method include question mark. So there are certain methods we can use off of strings. There are certain methods we can use off arrays. And they may not work with other data types. But I can check a method, dot. What was that, Michael? We can try. Dot include question mark. Same issue, because we're trying to call a method that doesn't exist off of integers. So you can't call this method off of our integers. So really what this looks like is you have like a class string. And what can you do off of a string? Well, you can define a method called include. But our class integer doesn't have that method. It has other methods. You can do a toS. So 1 is a number. I call this method called .toS. Does this work? Yes, it does. It transformed my number 1 to a string 1. The problem is it's not a matter of working with numerical values. It's not a matter of prints versus puts. That's not relevant to the problem of understanding which methods we can call off which types of data. So I can call an dot include off of a string. I can't call that off of a number. I can call toS off a number. That works just fine. Yes. Let's see. Let's try that. Dot include, does this string include the string 1? So number 1, convert it to a string, and then invoke this dot include question mark method off the string. Does it include a 1? Let's see. Yes. I've highlighted it over on the right. The string 1 includes the string 1. Okay. Of course. So let's talk about just this use case. Let's get rid of this. And I'm going to get rid of all this code. So Junior, before I press play, the only code I have is on lines 4, 5, and 6. What are they going to print out? We're not doing anything with dot select. You can ignore all of this. What is this going to print out?
So the first one, like what I'm thinking is supposed to print Anna and Ann. The second Ann and Ann, Sheena and Ann.
Okay, let's try that. Let's see if it prints the string Anna and Ann. So it doesn't, because how dot include works is it returns a Boolean. It evaluates to be true or false. The same way, if I put 1 is greater than 4, are we going to see the terminal print out the number 1 or the number 4, or are we going to see it print out a Boolean of true or false? Okay? Yes, so if we compare, that's always going to give us a Boolean. So these are some built-in methods in Ruby where if I say dot include, does something include something else? That's a yes or no question. That's a true or false question. Does the string Anna include the string Ann? Anywhere in the string do you see? Right, exactly. So now, how dot select works is it's always going to return a new array, but it's going to iterate through each one of these. And remember how dot map works is it takes in the name and it transforms it to be the length, or it transforms it to be the number 1, or something silly like that. So how select works is it's not going to take in some transformation instructions. It has to take in a Boolean. And that Boolean is, well, these are all Booleans. When I say dot includes, that's a Boolean. So when I say name dot includes, that's me remembering that name is going to be the string Anna and the string Anne and the string Gina. We're saying, does this string include Anne? Well, this is going to evaluate to be true or false. And only if it evaluates to be true do we want to keep it. So for the first one, we know that does Anna include Anne? True. The second one, does Anne include Anne? That's true. The third one, does Gina include Anne? That's false. So when we run this, Anna and Anne will return true, so we keep that in the new array. And Junior, I can't really see your face, so I don't know if I've answered your question. Okay, are you in a place where you can't use a face cam? Okay. So on a scale of 1 to 5, how are we feeling about dot select? 5 is I get it. 1, don't understand it. Cool, awesome. Let's test you guys. What if I do and what is this going to return now? Anyone in the group can answer. So you're right, none of them will have it, but what will dot select always return? An array. So in this case, well, so what did we put in? We put in A, N, 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 N. Does any string include that many n's? Exactly. Do the strings. So if I say A, N, N, this will give us Anna and Anne. T, what if I do a dot find? How does that change how my code will work? Okay, so what do you predict when I run we will get? Well, let's see. So that's exactly it. It's not the same thing as before, because the same thing as before was an array of Anna and Anne, or an empty array. In this case, we only get Anna. It's kind of like, yeah. So like back to the deck of cards examples. So if you have a deck of cards, I'm actually going to bring your attention back here. So if you have like a deck of cards, oh, is my screen is being kind of wonky. Can you guys see me all right? It looks like, okay, so if I have like a deck of cards, wow, my cards are all messed up. Oh, that is so weird. Okay, so I have like my 3 cards. If I say, find me a clover, well, I found one. I don't need to keep going anymore. If I say find all the clover cards, well then I have to like look through and say, oh, this is a clover, I'm keeping it. This is a clover, I'm keeping it. This is a heart. I just want to toss that. So how dot find works is you're only going to get the first one ever. Okay. Scale of 1 to 5. How are we feeling about dot find? Cool. Okay. Everyone else? Okay. Cool. Then I'll quiz you guys even more if you're so confident. If we say dot find include Anne, what is going to happen now? So remember that dot select and dot find all is always going to return an empty array. But when we said dot find, is the string Anna, is that an empty array? Or is that any array? That's just a string. So find is always going to return something, like not an array. Not an array. So in our case, when we say find me something that includes Anne, what we got was the string Anna, or whatever the element is. If this was an array of numbers, we would get, let's say, let's try numbers is equal to 1, 2, 3, 4, 5. So let's iterate through numbers and say, find me the number where the number is greater than 2. Ooh, what is this going to return? What do you think, Deja? So remember 5, find is just like, hey, as soon as I find one of them, I don't need to go any further. Like, okay, let's run that. It'll return 3. Perfect, so dot find doesn't return an array. It just returns the first element. Depending on that element, if it's a number, it'll return that number. If the element is a string, it'll return that string. But what if the element doesn't exist? What if we say find the first number that is greater than 1,000? So numbers.find, I'm going to go through all the numbers. Is 1 greater than 1,000? Is 2 greater than 1,000? Is 3 greater than 1,000? None of these are greater than 1,000. What's going to get returned now? And that's exactly it. We get a return value of nil. So that is all your enumerables in a nutshell. Is there anything you guys want me to go over again?
Can you go over how you would like nest the different enumerables within each other, like select and then keep the tag map at the end of it?
So we can do something where we can say array. So array is this. Let's say array.select where, let's do name, and then select where name dot include Anne. So all this is going to evaluate to be an array of Anna and Anne, because it goes through and says, hey, I only want to include the names that I want to select the names that include A and N. So everything that I have highlighted on my screen, all of that evaluates to be an array. And what can you do with arrays? You can call array methods off of them. So I can say this is an array. I can say dot map. Well, the array I have is Anna and Anne. What if I map it to say, okay, what is the thing I'm iterating over? I'm still iterating over a name, the name Anna and Anne, but I'm going to map it to name dot length. Knowing that the first half of the statement is the array Anna and Anne over on the right, what's going to happen if I map it and transform it to name dot length? What would you expect this array to be now? It'll be, let's see, so is it Anne or is it an array of 4 and 3? So it is, it's an array of 4 and 3. Another way to do this is you can say this is like first array. So all of what I have highlighted, we're going to store it in the variable first array, and then we could say first array dot map. Same thing, it's just how much do you want to break it down? Okay, let's go ahead and move on to our practice problem. So we have a domain where it says, word has just come out from the high-ups, you're in charge of building out a domain that keeps track of cars, their owners, and the mechanics that service them. Each car has its own classification, so antique, exotic, clunker. Each mechanic has a specialization, which is the same. So as a mechanic, I can specialize in exotic cars. I'm going to show you guys a neat little trick. So I've rewritten some of these deliverables to look more like the code challenge. In VS Code, you can click on this preview button, and it takes this markdown. So .md is just a markdown language, and it rewrites it to more or less what you would see in GitHub. So all of this gets transformed to be a header and some bold and some like code snippets and some text. There's a little, so if I don't have this, there's a little button where I can preview it. Open preview to the side. So moving forward, what do you guys like better? The preview version or the plain text version? Okay, let's stick with the preview version then. And what I'm gonna do is I'm gonna open up my other models over here then. So let's drag all this over here. Let's get rid of these files. Nope, I want it back. Let me get the car as well. Okay, so this is our README, and they tell you some stuff about the model. So each car owner may have a ton of cars. So this tells me I'm going to have let's do this. I'm gonna have this little whiteboard. Each car owner, I'll say car, that's a very bad car. Car owner. Each car owner has many cars. So that tells me that this is the start of my domain. A car owner has many cars. Okay, what else it says is each car owner may have tons of cars, yes, but these folks are fanatical about their maintenance and will only see one mechanic per car. So one mechanic per car. So that means one car, one mechanic. So that tells me, what does that look like? Well, I don't want you guys to get this idea of like pattern matching is always going to solve your thing, your solution. If we make this a many-to-many, we're just jumping too far ahead. What we know so far is one car has one mechanic. Yeah, you're right. This is the car owner. This is the car. This is the mechanic. Okay. So this, based on what I've read so far, is our domain. A car owner has many cars. A car, that one car is going to be served by a mechanic. And it's not until I read the next line, so one mechanic per car, but a mechanic can service tons of cars. So this means I have to update my diagram to say, hey, one mechanic is going to service many cars. It just so happens to be one car is serviced by a particular mechanic. So this means I can understand my domain. It's a many-to-many. A car is going to belong to a car owner and a mechanic. A car owner has many cars and a mechanic services many cars. Let's think about like what that means. Let's say in another world, car owners are me, Chine, and the instructors. So like in a different world, we are car owners, and then your classmates are our mechanics. So Beza and Danny and Brett are all mechanics. I might have a few different cars. I have my Toyota and my Honda and my Nissan, and I only care about those cars. And maybe there's tons of mechanics. Maybe there's 15 different mechanics, but I'm only going to care about the mechanic that serves each of my 3 cars. Well, what does that mean? Well, my Toyota is serviced by Beza, my Honda is serviced by Danny, and my Nissan is serviced by Brett. I'm only going to care about Beza, Danny, and Brett. So those are my mechanics. I'm not going to care about the rest. Now, let's talk about our starter code. So it tells us that you have a car owner, and then car is going to be the middle table, and then you're going to have mechanic. I'm going to see if I can fit 4 to a screen. Okay, that kind of works. You guys can kind of see everything. Let's talk about the deliverables. So what we have so far, we have our initialize. We have our car owner. I'm going to do this. Car owner. We have our car and we have our mechanic. Now, I again don't want you guys to get in the habit of just typing things that everyone else is typing. Let's understand why. So in order to run our code, we're very much used to saying Ruby and then tools and then console.rb. And that has always, I need to bundle install in order to install these gems. Okay, it's gonna download. Okay, it's downloading all that stuff. And now we're used to saying ruby tools.console.rb and then we're magically in a pry. Now I don't want you guys to get too comfortable with that because we need to understand what we're doing. When you say Ruby, what you're really saying is you're just saying, I'm gonna give you a Ruby file and I want you to run it. So let's say car owner. I am going to go ahead and literally just inside this file, I'm going to create a new car owner. Let's say Anne is equal to car owner.new, pass in Anne. Then I'm just going to print out Anne. So we've never done this before, but how Ruby works is if in my terminal, I type this keyword Ruby and I give it the name of the file. So I have to go, based on the folder structure, I'm actually going to have to go inside my app folder and then inside my models folder. So app/models/car owner. And at this point, I'm just going to hit tab to autocomplete and it autocompleted for me. If I run this, look at that. Something was printed out and that something was a car owner. Now, if I wanted to, I can throw in a binding.pry right here. And this is going to error out in a little bit because it says undefined method pry. If I wanted to test my code and use pry in this file, running this file, I'm actually going to have to require pry. The reason you guys didn't have to do that before is because in your, I can show you guys, in your console.rb, when you say require relative, that is going to require pry. How it does is inside your environment.rb, when it says require everything, this is requiring pry. So that's why you usually don't have to require pry, but in this case, what I want to show you is that Ruby is just Ruby. It's not magical. It's just, we're saying, Ruby, run this file from top to bottom. So I'm going to run literally this file all the way on the left from top to bottom. I'm going to create an instance of Anne. I'm going to print that instance of Anne. That's what you see down here. And then I hit the pry. And I can look at Anne. And I have an instance of car owner. It's not all magical. So on a scale of 1 to 5, how are we understanding just the files and running the files? Is it making sense? Okay, 5. Anyone like a 3 or 4? Because why are y'all here if you're mastering everything? Okay, that's okay. Let's go ahead and what's up, Michael? Of course. So when we say Ruby, that's saying run some Ruby file. So what I could do, I could even say in this top level folder, I can create a new file called ann.rb. And all this is going to do is going to say x is equal to 1, y is equal to 1, z is equal to x plus y. So with that math, Michael, what would the value of z equal? 2. So I'm going to put z is equal to, and then I'm going to interpolate z. So what I can do is I can do ls, and I can see what files are in my folder. So here's ann.rb. I can say Ruby, run this Ruby file, run ann.rb, and what's it going to do? It's going to print out z is equal to 2. I don't know how the SQL labs were established. But so wanted to establish a baseline. All we're doing is when you say Ruby and tools console.rb, that's not just a magical pattern. It's saying, hey, run this file from top to bottom. Just like we can say, here's car owner.rb. I'm going to run it. I have to first go to it, car owner. I'm going to run it from top to bottom. I hit this pry. And if I wanted to, I could test my code here. I could write out a method given a car owner name, get the name of the car owner. Once the name is set, it cannot be changed. So this is the approach I want you guys to take when you're working through these deliverables. When it comes to creating these methods, there's 3 things to kind of keep in mind. Those three things are like the type, the method name, and then the logic. So in our case, car owner hashtag name. What type of method is this? Sebastian, is this an instance method or a class method? It's an instance method. So I'm going to define an instance method. And then Junior, what is the name? Oh, whoops, crap. Sorry, I'm gonna hover my mouse over here for you. What is the name of the method that we are supposed to be writing right now? Name, it's just name. So the type of method is an instance method. The name of the method is called name. And what's the logic? Well, the logic is we want to get the name of the car owner. So what we can do is return the instance variable name. Let's see if this works. If I kill this, I can say, okay, Anne is my instance. Car owner is my class. So I'm inside my binding.pry, and neither of these, when I type them, resulted in an error. So if I want to call this instance method, I call it off of an instance, and it works. What is a more succinct way to write this? What do you guys think? What's up, Deja?
I was gonna answer, but that's what I did. Okay.
Mm-hmm. So that's exactly it. We're going to create an attribute reader. And I want to make it very clear that what this is doing, this is writing a method for us. So when I say something like Anne.name down at the bottom, Anne is an instance. We're calling this method called name. Where did we write this method? Well, we didn't write this method, but we got Ruby to write this method for us. Works out the same. Let's do carowner.all. So before we even do that, I don't even need to look at this README. I want to review class methods and instance methods real quick. So I'm going to say def over here, and it's going to print out over here. Over here. I'm now going to create a method called self dot right here. I'm going to print out right here. Okay. So what I'm going to do, I'm going to restart my Ruby application. And when I say Anne.over here, Michael, what would you expect the terminal to do next? Oh, you're muted, Michael.
If you did that, I would expect it to print
Print out
out and over here.
the word and over here, or just the words over here?
Print out the word.
Let's see. So we don't see and over here. We only see this. So reminding ourselves the format of a method. A method has a type and a name, and inside of it is the logic. In this logic, we never said print out and. We just said print out the words over here. Let's do something else. If I do and dot right here, Sebastian, what's going to happen? You're muted. Let's see. So it's going to print out the string over here. Okay, let's try it. So the method is and right here. So you're saying it will print the string over here. Is that correct?
So what I thought would happen the first time was you'd be looking for inside of the instance and you'd be looking for an over here.
So let let's talk about that then. So we're going to clear out that misconception. So these instance variables have nothing to do with methods per se. I could have, at over here is equal to I'm going to say is equal to the number 1000. If I say and let's run this owner.rb and dot over here. When I say dot, this has nothing to do with instance variables. You cannot call instance variables off of an instance. You can only call methods. Just when I said, before when you saw like and dot length. Dot length was a method that you would call off this and string. 1.2s. 2s is a method that you call off of the number 1. And dot over here. Over here is not an instance variable. It is a method. So if that's the case, where is the method over here? On line 8 or on line 12, Sebastian? It's on line 12. So when we say and over here, that is not going to print the number 1000. It is going to look for a method called over here. But why does name and dot name? Why does this work? There's a method. So attribute reader name is saying create a method called name and look for an instance variable of the same to return. Okay. What's up, Michael? So when I said and dot over here, this is a method. It has a type, it has a name, and here is the logic. Only on line 13 is the logic or the thing that this method is going to do. It never says print name, it says print over here. What's up, Junior? Right, we're always calling a method every time we say and dot something. I'm not sure I understand your question. Mm-hmm. Right. If it returns what you expect it to, that's how you can test if it works. Yes. Let's do that. And dot right here. Uzo, what makes you think it'll be an error message? So let's take a look at this. Every method, remember, has a type, a name, and a logic. Let's do T. What type of method did I create on line 17? An instance method or a class method? It's a class method. So when I do an instance dot right here, we get undefined method right here. So you have not defined a method called right here that is an instance method. So Ruby's going to error out. If I wanted to, remember that I am stuck in my pry on line 26. If I type and, that's an instance. If I type car owner, this is my class. So what would I need to type, Junior, in order to reach this logic on line 18? That's exactly what we need to do. So every function, every method has a type, instance method or class method, the name, which is right here, and then the logic you want to do. If I said, let's try car owner dot over here. Ooh, is it going to work? Is it not going to work? Error, because we're calling a class. So Ruby's going to look for a class method called over here. Does it work? No, it doesn't. Okay, so we have written it as an instance method, not a class method. That's exactly right. I'm going to break your brains one more time. For both of them, I'm going to print out over here, and then I'm also going to print out self. And we're going to play a game of what's going to happen. So we already know if I want to call over here, what type of method is this again? Anyone can answer. Instance or class? Instance. So I need to call it off of an instance and dot over here. And what is it going to print as self? That's exactly it. It's the and instance. But let's call this code. Let's run the logic in self dot right here. How we call this is car owner dot right here. And what is this going to print? It'll print right here, and then it should print out, ooh, I need a P, should print out self, and we're going to have to make a guess as to what we think self is going to be when we say car owner dot right here. Car owner an instance or car owner the class or what? That's exactly it. We printed out car owner the class. So inside an instance method, self is referring to the instance. Inside a class method, self is referring to the class. It's always like, what scope are you currently in? What is the scope or the type of function? Is it the scope of the function, is it an instance method function or is it a class method function? Okay. That aside, done. I'm going to put this down here, but I'm going to comment it out. Let's now work on the next deliverable. We wrote the function where given a car owner instance, we are going to create a method called .name that returns the name. But we now need to create a way to get all of our car owners. So let's think of the type, the name, and the logic for car owner.all. So car owner.all, T, is this going to be a class method or an instance method? Class method. So we're going to create def self.all, and the logic is I want to return all owners. But how do I do the logic for that? Deja, what would I have to create and what would I have to type to get this to work? Mm-hmm. Exactly, that's what I want to do. Yep. Okay. And what do you want to call this class variable? All owners. I like that. And what data type should this all owners be if we want to return all the owners? An array. Perfect. No, that's perfect. So now, Junior, how would I make sure all owners are going to get a new owner every time an owner is created? So we initialize it on line 6. Careful with the terminology. So let's shovel self inside this array. So remember, inside, this is an instance method because we don't see self. Like that, then it's a class method. So inside an instance method, self is the owner instance that we're creating. Yes? Perhaps if you didn't, maybe when you initialize a new owner, you didn't necessarily want to save them to a database just yet. Maybe they have to finish some sort of registration and then you want to save it. But it's kind of a not a very often used case. Okay, so T, on line 17, what is the logic I actually want to write in order to have this method return all the owners? right? So we did that on line 6. Deja helped us out with that. So we're just going to return this class method. Let's test to see if this works. So what I've done is I'm running literally this entire carowner.rb file on the left. I've hit my pry. I can check, okay, how do I call a class method? Well, I call it off of a class, car owner, and I call the name of the method, which is .all. And now I get all my car owners. If I had some other ones, Chine is equal to carowner.new, Chine. Let's kill this. Run it again. We get carowner.all. We get all of our owners. What I'm going to do at this point, since we've gone over it, there's no real value in doing it again. So I'm going to quickly initialize all of these files to have this class method all. And then what I'm going to want to do is I'm going to want to shovel self into it. Same thing here. At all is equal to an empty array. I'm going to define a class method called all. It's going to return this array, but I'm going to need to make sure every time I initialize a new mechanic, I'm going to shovel it into here. And what I'm, oh, there we go. Okay. Now, this is where things get a little bit tricky. I'm not going to spend too much time on this, but what I'm going to do is I'm going to create a couple of mechanics as well. So I'm going to say Beza is equal to mechanic.new. I'm going to say Beza specializes, whoops, Beza specializes in antique cars. And then I'm going to say Brett is a mechanic.new that specializes in exotic cars. Okay. This is where things get a little bit tricky. I could run. I'm going to put a binding.pry here as well. And I'm going to require pry at the top. Require pry. If I attempt to run this mechanic.rb, I'm going to run this file. I hit my pry. I can look at Beza. I can look at Brett. And I can even look at mechanic.all. That works. One thing, though, I won't be able to do is if I say carowner.all, I'm actually going to get an error because the way these 3 files work right now is they're all very independent. If I say run this file, it's only going to run this file and no other files, and I won't be able to access my car owner or my cars at all. What questions do you guys have? What's up, Michael?
Let's say you wanted to print each element of the array, car, owner, all, mechanic, all, on each element on a new line. How would you go about doing that?
That would be a .each. So for each mechanic, you just want to print out that mechanic. All right, Deja, you had a question. Right, so you even if you tried, you won't be able to use Active Record because it's not installed in this code challenge. So how's everyone so far? How are we feeling about class methods and instance method, like scale of 1 to 5? Okay, looking good. So we can move on to now like integrating them together. So I want you guys to just understand why we set up the code the way we do. Right now we're running like mechanic.rb by itself. That's how we got here when we said in the terminal run Ruby app model mechanic.rb. It's just running this file. The reason we create a separate file for you is because we actually want to access all three. That is where console.rb comes in. We're saying this file, when I run it, I'm going to kill my pry. When I say ruby tools/console.rb, when I run this, that is going to run this file from top to bottom, and it's going to stop me on line, oh, it should have stopped me on line 7. Let's try that again. Kill my pry, ruby tools console.rb. Okay, I know what I did wrong. Let's get rid of this pry. And let's get rid of this pry. So when I run console.rb, it's going to run this file from top to bottom and stop me on line 7. What we do is we say require relative environment.rb, and in that file we say require everything inside the app folder, which is our car owner, our car, and our mechanic. So I wanted to make sure that you guys could see how Ruby works. You can code Ruby anywhere. But the reason we code in our console.rb is, I can take all this stuff out, is because in here, now that we're in my console.rb, now that I've required environment, I've required app, I've required each of the 3 individual car owner, car, and mechanic file, I can access car owner.all. Now in here, let's go ahead and create. So before, like, this is where my data was, that's where it's coming from. I'm just going to cut and paste this, put it over here. Let's do this. So here's my console.rb. Over on the right, I'm creating Anne, Chine, Beza, and Brett. I can look at Anne. It's an instance of a car owner. That's what this is down here. Car owner.all, mechanic.all. Whoops. I can't spell mechanic to save my life. Works all the same. I could even look at car.all. It's an empty array. Okay. How are we feeling so far? Okay. I'm going to ask you guys to take a 5-minute break. We'll come back at 3:20. Go watch like a cat video, like go stand up, do some push-ups, do all that good stuff, and we'll be back soon. We've established that the car is going to be the join table. So if what we know about object relationships is true, a car is going to have to keep track of its owner and its mechanic. The current starter code actually does not have that and expects you to make that decision that you need to initialize a car with a car owner and with a mechanic. So we're going to change this up. We're going to say a car should be initialized with an owner and a mechanic. And I'm going to create this as instance variables. So I'm going to create an instance variable called owner. That is going to be equal to the owner we pass in. And we're going to create an instance method called mechanic that is equal to the mechanic we pass in as well. So let's go ahead and make some seed data. So car1 is going to be car.new. Let's say we pass in Anne and Beza. Okay. Mechanic. There we go. I don't have the right letters. I just always make it an anagram. That's all right. Let's say I have a Honda, an antique one. I don't really know cars. I'm just going to say Honda CRV. That's actually my car. And the classification, let's just say it's an SUV. Okay, car number 2, car.new. I'm also going to own another car where I say, I go to Brett and I have a, I'm going to do my mother's old car, Toyota, and, oh, I forgot what it was. Sure, that is one. Camry. and it is a sedan. I don't know. And then we'll say car.new. This is going to be Chine Beza, and she can drive a Hyundai Sonata. And it is, let's say it's an antique. I don't know, antique. Okay, so let's see if this all works as expected. So I shouldn't get any errors, and I don't. If I say car.new, that works great as well. Let's now go back to the README and double check what we've done so far. So given a car owner, so given Anne, we've created a method called .name with the attribute reader. That works wonders. We created car-owner.all. Let's create a car.classification, because right now this method is undefined. And classification, once it is set, it cannot be changed. So let's create an attribute reader for classification and test this out. So given car1, can I get its classification? Yes, yes I can. Notice I didn't do, make, model, all that stuff. I don't want you guys to get in the habit of doing that just because you feel like you need to. You could, but that's not what the instructions is asking for. The instructions is asking for an instance method called classification, and we made a method called classification using this attribute reader. We could make more methods called make and model, but we also don't have to. So I'm going to leave it at that. If I don't have a attribute reader for make, well, that means I don't have a method called make, just like I don't have a method called model. Okay. Scale of 1 to 5. How are we feeling about attribute readers and methods? Okay, cool. Let's now, so we what's up, Michael? So when I say car1.model, undefined method, inside my car class, I didn't create an instance method, nor did I create an attribute reader. So this method does not exist. That's why it will error out. And it doesn't exist because according to my instructions, I don't have to make it. Okay, given a mechanic, so given Beza dot name, this doesn't work. Let's create some methods for Beza. So we've gone over this a couple times. Let's create an attribute reader for the name because once the name is set, it cannot be changed. And let's create an instance method called specialty. I think I spelled that wrong. Specialty. Yeah, not speciality. That was my mistake. So I should have a method called specialty that gets the specialty of the mechanic, but I should be able to change this data. So I'm going to create an attribute junior. Which attribute should I create? Reader, writer, or accessor? You could. Not always the best answer. Uzo, why would we want to create an attribute accessor based on the instructions? So we want to be able to change this. Well, in that case, why don't I make a writer? Is there anything else in the instructions that says this has to be a reader? Let's check again. So does anything in the instructions say we do need to read or get the specialty of the mechanic? So what is this highlighted? What does this say? So it should be able to change, but what about the sentence before? Get the specialty. So that's, as a developer, you'll have to interpret that. That means, oh, I need to read this attribute as well as write this attribute. So Junior, you're right. Attribute accessor is the right thing to do. But why? Not because it's easy, because that's what our features are in need of. We need the ability to change it, and we need the ability to just get it. It depends. Sometimes you have a writer, and then you have a custom reader. So in that case, you wouldn't have an attribute accessor. So specialty. We're not going to test it. We're just going to assume it works because we're just going to move on to more stuff, which is relationships. Okay, this is fun. So, car owner, cars, T. Let's talk about this method. So every method needs to have a type, name, and logic. What is the type of this method, car owner hashtag cars? Instance or class? It's an instance method. So we're going to create a method that's an instance method with the name of cars. And the thing we have to actually build out is the logic. So the type and the name, we can figure that out based on the instructions. But the logic goes here. So let's put in a binding.pry. And let's just test to see if we can reach this. So Deja, I'm in my console.rb. I have access to Anne and Chine and Beza and Brett. I'm frozen on time on line 18. Deja, how would I hit the binding.pry on line 20 over on the left? Exactly. And that's exactly correct because now I've hit the pry on line 20 of my car owners. Now let's talk about the logic we want to do. So the logic, or what this wants us to do, is get a list of all the cars. So I'm literally just going to write this. Get a list of all the cars that owner has. Okay. Well, one thing we can do, get a list of cars that owner has. I can access the owner inside this instance method. What special keyword would I have to use, Sebastian? You're muted. So the instruction says car owner.cars. We need to get a list of all the cars that this owner has. So how would I? So the question was, we want to get a list of cars that owner has. That owner. How would I access that owner inside of this instance method? So I called Anne.cars. How do I access Anne?
Well, I was going to say we do like a car.all.select, and so that you can select the cars.
So you guys know what to code, but I'm not convinced you know why. And we're going to take a step back and understand our code, not just understand what to write. So I'm going to open this up. How would I access, if I say Anne.cars, how would I access Anne inside this method? Self. And that's exactly it. So remember, inside an instance method, self refers to that instance. Now, you guys are right, Sebastian is right, in that if we want to get a list of cars, Anne isn't going to be enough. How would we get all the cars in general is car.all. That's correct. This is car.all. And Sebastian, you said something about select. Why would we want to use select?
Because an owner can have more than one car, and we're not just trying to get one of the cars that an owner has. Hence why we want to use select or find all.
Okay, so if I have self, so self is Anne, and I have car.all. So there's, let me make this even bigger. Trying to figure out how I do that. Okay, cool. I'm gonna clear this. I have self, and I have car.all. So here are 3 of my cars. Now, which one of these cars do I want to select? All of the ones where the owner name is Anne? You're definitely on the right track. What that would look like. So we definitely want to say, like, get me all the cars, and then only select those cars where the owner name is Anne. So this is what that would look like. This would say car.all.select do end, and The thing I'm iterating over is a car. So car.all, that's what this is. The thing I'm iterating over is a car. If I want to say where car dot, and if I want to get the name of the car owner, let's put a binding.pry right here. Binding.pry. So let's, whoops, we have an error on line 25. That's fine, I'll get rid of it. Let's start this up again. Okay, so an.cars. I've hit my pry. I know that self is an. I know that car.all is our cars. So now that we're in a pry, we can always check self, but what is something else that we should always check inside an enumerator? I want to see what's inside this pipe. So in this case, it's car. So if I wanted to check the name of self, well, that would be self.name. That makes sense. And if I want to compare that to the car, so remember that this is our car, I can say car.owner. Why doesn't this work? Michael, that first part was on the money. Inside of our car, where do we define a method? So car is an instance of car. Reminding ourselves, car is an instance of car. Car.owner, we get an error, undefined method. Inside our car class, where do we define? There is none. So Junior said there is no method called owner. How do we define a method called owner? We define a method like so. It depends. In our case, the instructions doesn't specify, so we could do either or. Only when I create this method, now when I say, okay, and.cars, I've hit the pry. What is car? Car is all this. Car.owner, now this method exists. And then if I say, okay, car.owner is going to give me an instance of car owner, .name, does a name method exist for our car owner instance? What do you guys think? Does this method exist? I see head nodding, yes. So this should work. It's the string and. So we very well could say car.owner.name, compare that to self.name, but there's a better thing we could do. We could compare car.owner. So let's take a look at the car. So the car is a Honda CR-V. It's an SUV. The mechanic is Beza and the owner is Ann. I can say, what is car.owner? Stop right there, and I can compare that to self. The benefit of this is, say you have two different car owners, both named Ann, but they're two different car owners. You're not going to be able to tell the difference if you're only comparing the names. You want to compare the whole objects. So, what we're trying to do, we're trying to get all the cars. And we only want to select those cars where the owner is self. So what we're going to do is we're going to say, iterate through all the cars, select all the cars where car.owner is equal to self. If I kill this, if I say Chine.cars, that doesn't get all of Chine's cars. And.cars, that's going to get Ann's 1 car, 2 cars. On a scale of 1 to 5, how are we feeling about this cars method? Okay, for those who did participate, I think we're good to move on. Okay, Junior, so what questions do you have about this method? Okay. The car owners class, yep.
So 924, what I was thinking is car owner equals
So car, are you saying car owner?
no, but this could be the class. We're not comparing the class itself because in this case, the self is and.
Self is and, that's absolutely it. If we said and dot cars, the value of self is going to be and dot cars. So which line would you want to dive deeper into?
Not a line. I just want to like know where that owner came from.
Yeah, let's take a look at that. So we're going to put in this binding dot pry. So this is what we're going to do. We're going to say, show me car.all. Okay, car.all is an array of 1 car, 2 car, 3 car instances. That much make sense? Okay, now when I say and.cars, we're going to hit the pry inside of our loop. So now at this point, remember that this is all 3 of our cars. Car at first is going to represent just the first one, and then it's going to represent the next one, and then the third one. So if I look at car is an instance of our car class. Okay, so perfect. Okay, no, that's perfect. So that's why we have these more intimate sessions. So we have done all this. Let's define our next method, which is going to be carOwner.mechanics. Okay. So what are we going to do? We're going to look at the type, the name, and the logic of this method. So the type is an instance method. The name is mechanics. And let's hit this binding.pry. So if I want to call this instance method of mechanics, I have to call it off of a car owner instance. So an.mechanics, I hit my pry, and at this point, let's talk through the logic. I want to get a list of all of this owner's mechanics. So T, how do I get access to this owner inside this method? What keyword would I use to say, hey, an.mechanics, I want to access an inside this method? That's exactly it. So I can get access to self, and I want to get a list of Anne's mechanics. Well, self doesn't provide me any useful information on Anne's mechanics. I can do mechanic.all. Okay, mechanic.all, does this provide me any information about who Anne's mechanics are? No. So what I'm going to have to do is I'm going to have to first look at car.all, sift through and see which one of these specify Anne with the mechanic. Now I could write out all that logic, but do we already have a way to say, hey, Anne.mechanics, I know self is Anne, so self is an instance of Anne. I have all sorts of instance methods that I can call. Do I have an instance method that is going to return me a list of Anne's cars? I see head nodding. Yeah, so self.cars is going to give me a list of Anne's cars. Self.cars, this is Anne's cars, or really like this owner's cars. And then from here, I have an instance of a car, and inside of it, I see that there's a mechanic. I have another car. Inside that, I see that there's a mechanic. What is a good way to say, here are the cars, but I only want to collect the mechanics? Junior, you can answer this one. Yep, that's exactly what we're going to do. We're going to use self.cars, and this is what we get. So that's exactly it. Now that we have Anne's cars, we can go through and map, and careful not to say I want to select Anne's mechanic because that could get confusing, but what you're doing is you're iterating through cars, and you want to collect, here's my first car, I already know this belongs to Anne. Here's my second car, I already know this belongs to Anne. I just want to collect the car, let's put a binding.pry in here, binding.pry. And I'm going to run this code. So I'm going to say Anne.mechanics. Okay, I already know self.cars is going to give me just Anne's car. So if I look at the car I'm iterating over, what transformation do I have to specify to just get the mechanic? I'm going to open this up to Deja. Well, remember that how .map works is a this is interesting, car.mechanic. I get undefined method mechanic. Well, in my car class, do I ever specify a method called mechanic? That's exactly it. So if I do and.mechanic, so I'm inside my map, here's my car. So how a .map works is you don't need to put in a condition because you're not saying here's all the cars, I only want to select a few. You're saying here's all the cars, I want a one-to-one mapping. That's exactly it. So car.mechanic, if we put this in here, this is saying, hey, I want to create an array, and also because this is the last line of the method, I'm going to automatically return it, where self.cars, that's all of Anne's cars. Given my two cars, my Honda and my Toyota, I want to say each of those two cars has one mechanic each. Get me those one mechanics, and what I'm left with is my array of two mechanics. So Anne.mechanics, mechanic Beza, and mechanic Brett. How are we feeling about dot mapping on a scale of 1 to 5? Okay, looking good. So what I'm going to do, I'm going to skip over car, well, we actually can just show you now. So given car 1, can I get its mechanic? Does this instance method exist? Yes, because we built it out literally 5 seconds ago. Car 1, car owner, like car, hashtag car owner, so that's an instance method. Given an instance of car, can I get its car owner? Oh, in our case, I called it owner. But yes, I can get that as well. So I need to change this. This should be, I can't change it. Okay, I'm going to just go ahead and build out the opposite relationship. It's the exact same thing. So given a mechanic, I need the ability to get all of their cars. What that means is I'm going to have to select all the cars, or find all the cars, and then only select the cars that belong, not cat, that belong to this mechanic, where car.mechanic is equal to self. So given a mechanic, how do I get all their cars? Get all the cars, period, and then select where the car's mechanic is self. Finally, given a mechanic, how do I get all of their car owners? Well, first thing I can do is given a mechanic, how do I find all the customers that I serve, all the car owners that I serve? Well, let's only look at the cars that I serve. Self.cars. This is going to give me an array of only the cars that I, mechanic Beza, serve. And then from there, I serve this Honda and I serve this Toyota. Who are their owners? I can say dot map do car, and given a car, I want to transform it to the owner. So let's test this. Mechanic Beza dot car owners. It's going to give me Anne and Chine. That's because Beza services my Honda and Chine's Hyundai. I realize I spelled that wrong. That's okay. Brett dot car owners. Brett only serves this Toyota, which belongs to Anne. So Anne is Brett's car owner customer. Now, here is the fun part, aggregate methods. This is where you are going to flex your problem-solving brains the most. So, car.classifications. Let's do Sebastian. So each method has a type, a name, and logic. Car.classification, is this a class method or an instance method? That's a class method. So let's go to the car class and define a class method. And then the name of it is classification. Dot classification. And I'm just going to put a binding.pry right here. Binding.pry. Okay, let's talk about how I call this. Let's do T. How do I hit this binding.pry on line 19 inside my car class? Car.classification, classification. And that's exactly it. Notice I didn't say car1 classification because car1, car2, and car3, those are instance methods. Now, get a list of all car classifications. This is the logic that I need to fill in. Get a list of all car classifications. Deja, what methods might already exist that I've created that might help me with this? Getting a list of all car classifications. Yep. Yep, so car owner has, yep, go ahead. Okay, so like and.cars. Let's and. Okay, so right now we're currently in this method. So we're kind of stuck. We're currently on line 20. If I look at self, so that is going to give me car. Now remember how I got here? Let's backtrack a little bit. So we're in car.classification. We're on line 20. And remember self, inside of a class method, is the class itself. But we always have access to a few things. We always have access to like carowner.all, car.all, mechanic.all, and self. So which methods might be useful for getting a list of all cars classifications? So we can look at carowner.all, mechanic.all, and we can look at car.all. So we're not on an instance of car. If we look at self, we're on the car class. That's because how we called this method, we called it, car.classification. Let's do this. So carowner.all, does it give you any information about car classifications, Deja? Yeah, okay, so we looked at mechanic.r. Does it tell you anything about car classifications? Yeah, so if we do, that's exactly, so car.all. Whoops. We're inside car. And so what classifications? So SUV, sedan, antique. So let's take a step back. We have car.all, which is an array of 3 car instances. How would we get SUV, sedan, and antique out of this array? Sebastian, what do you think? Okay, car.map. And what are you thinking as far as what we're mapping? Classification. Look at that. Remember what .map does. It takes a 3-dimensional world and maps it to a 2-dimensional space. It transforms it. We have an array of 3 cars, 3 car instances. We wanted an array of 3 strings. So how do we get that? Well, we have 3 cars. If I just want to collect the owner, you guys know how to do that. You know how to say given car.all, collect the owners. So given a car, how do you collect the classifications? Same concept. So let's see. So car.classification. So car.classification.all. So here's the problem. When we say car.classification, we're going into this method. So if I were to say something like classification.all. Here's the problem. I call car.classification. That method is going to call car.classification, which is going to take us to this method, which is going to run this logic, which is going to take us to this method, which is going to run this logic, which is going to, and now we're stuck in an infinite loop. So that's not going to work. But what is going to work is problem solving. If you want to get all the cars' classifications, start with getting all the cars, period. And then from there, you want to collect just the classification. It's kind of like, let's say you work at a car dealership and someone, your boss, tells you, hey, I want you to tell me all the types of cars we sell. Well, you could be a lazy employee and just guess, oh, I think we have an exotic car and an antique car. I think we sell sports cars. I don't know. Or you could go out, look at every car and say, okay, we have an exotic car. I see an antique car. That is what .map is really doing. Okay. Of course. The car owner class, yes. You could. It's the same thing. It's a better practice to do self.cars.map because you're being very explicit that, hey, I'm on the Ann owner instance. I want to call this cars method off of Ann to get me a list of Ann's cars. You could say, owner's cars is equal to all this. And then but at this point, you're not really doing anything with this variable. So yep, you can do exactly that. That would work. Okay, so when it comes to getting all the classifications of a car, you know you can get all the cars, you know you can get all the mechanics, and you know you can get all the owners. What is actually going to help you get all the classifications? Well, you're going to go through all the cars. So map the car, and what you want to map it to is the car.classification. If I kill this pry, and I say car.classification, that is going to get me all my car classifications. And then I could say car4 is equal to car.new. Let's pass in an, let's do Chine, Brett, and then the make is, Chine also owns a Honda, but I'll do a Honda Accord, and it's the latest one. So for example, it's a sports car. I now have a new car. What is car.all? It's 1, 2, 3, 4 cars now. Car.classification is going to give me my 4 classifications from my 4 cars. Scale of 1 to 5, how are we feeling right now?
I just had one question.
Of course.
I think Junior asked about this earlier. I just wanted to make sure I got it.
Mm-hmm.
So in mechanics, you originally had like self.cars.map, I think, in carowner.rb.
Yep.
You have it there too, I think.
Mm-hmm. Right here.
Yes, yes. So you were saying that cars.map through car is exactly the same as self.cars.map through car.
Yes.
Okay, but self is better practice.
Yes. Okay. T and Michael, how are you feeling about the self.classification?
I understand it a lot better. So essentially, like in the car owner's map, you're taking the instance method cars and then transforming it with the car owner and mapping all the car instances from the mechanic to that
Yeah.
car location.
I think we're talking about different things, because I was talking about self.classification. Were you talking about that, or were you talking about the mechanics and the car owners?
I was talking about the concept of mapping.
Yep. Mm-hmm. Exactly. Concept of map, same thing in any of them. It's just a different practice. What is it that you want to collect? Do you want to collect the car's mechanic, or do you want to collect the car's classification into a nice list? T, did you have anything you wanted to ask, or?
So in the console,
Mhm.
we had this classification method under like car owner. So I was confused if we were supposed to put it in the car owner RB.
So we have it in, so self.classification, that is according to the instructions, that is a, where is it? Car, it's under aggregate, so car.classifications. Oh, I misspelled classifications, that's what it should be.
But you see how it says car owner? That kind of threw me off.
I see. That was my mistake because I spelled that wrong. Yeah, so let's do this. So I edited this file during lunch. So what it should be is, okay, this aggregate method, this belongs under cars. Okay, and now we can go back to the preview. We can kill that.
In this mechanics method, where are you getting the cars method is coming from that class car owner?
So car owner, yes, car owner has a class, a method called cars that we use inside mechanics.
How come you assigned it to a variable?
So because you can do either or. You can say self.cars. This is going to give me an array of all of that owner's cars. I assign it to a variable because I can.
You could also just self.cars.
Yes, you are now at the point where there's a million ways to achieve the same thing. The more important thing is understanding why it works. Okay, let's see what other aggregate methods. Okay, car owner dot average number of cars. Okay, Michael. So this method that I've highlighted over on the right, it has a type and a name and some logic. Is this a class method or an instance method type? Oh, Michael, you're muted. It is the class method type, yes. And I keep, I'm so sorry guys, I keep accidentally clicking away. Self.average number of cars. Okay, so get the average amount of cars owned for all owners, okay? Binding.pry. Let's see if we can hit this method. So if I want to hit this pry, I have to call it off of a class, the car owner class. So car owner dot average number of cars. I hit my pry. Okay. I can look at self. Self is the car owner class. That makes sense. Self inside a class method is the car owner class. But I can have access to car owner.all, car.all, and mechanic.all. Which one of those would be best? Let's do Uzo. Which one of these would be the best in order for us to get the average amount of cars owned for all owners? Car owner.all. Okay, so this is good. This will get me a list of car owners. Now, it doesn't tell me how many cars they have, but maybe it's a starting point. So maybe I can figure out how many cars each of these owners have. Let's still work on that pry. Let's say car.all dot let's just say each. When you're not sure, we can always just do a dot each. And we can say for each, sorry, this is car owner. So for each owner, let's put a binding.pry right here. Okay, so let's do this. Car owner dot average number of cars. Okay, so I'm inside my car owner.all. I'm doing a dot each. So here's my first owner. Given I have an owner instance, are there any helpful methods that will tell me how many cars this owner has, or how many cars like I can see from this owner? So given a car, So car.all, we're already inside. So car.all is going to give you all the list of cars, but given an instance of owner, any methods where I can say like I can get all of this owner's cars? So given an owner instance, this is an owner instance, I can say owner.cars, and I get an array of all of Anne's cars. How do I know how many cars Anne has? That's exactly it. So if I type exit, then I'm still in my loop. Who is my owner? It's Chine. Owner.cars is going to give me all of Chine's cars. How do I know how many cars Chine has from her array of one car? .count. So what I can do is I can say, instead of binding.pry, let's just like print owner.car.count. Let's just experiment. So I'm going to say car owner dot average number of cars, and I get O. So owner.cars.count. That's my mistake. Let's try it again. I'm going to say, okay, so did that actually work? How come it did not print? Puts owner.car, car owner. So the reason we get this array is because dot each is going to return the original array. Let me try to puts owner.cars.counts. Let me see if this works. So given car owner dot average number of cars. Okay, that works. So I was able to print out 2 and 1. What's the average of 2 and 1? 1.5. But now I have to calculate that. There's many ways you can do this. We can say something like, let's say total cars is equal to 0.0. Total owners is equal to 0.0. So let's do this. As I'm iterating through all the car owners, I want to keep track of the total cars. So I'm going to say plus equals. So the first time around, Anne has 2 cars, so total cars will change from 0 to 2. And then Chine will have 1 car, so total cars will change from 2 to 3. And I'm also going to say total owners plus equals what? And anyone can shout this out. Like every time I iterate through an owner, how many additional owners should I add to my count? 2 owners? So every time I iterate through an owner, I'm going to add 2 more. Just the one. There are 2 owners, but it's more important to understand the thought process than the final answer. I think a lot of you guys, you're smart, you know the final answer, but let's break down and understand how we get there. So binding dot pry. Okay, let's say car owner dot average number of cars. Okay, after the loop, so I've hit my pry after the loop, what is total cars? It's 3. What is total owners? That's 2. So I just want to return the total cars divided by the total owners. This is just math at this point. So car owners dot average 1.5. What would you guys like me to go over again? Deja, what's up? I'm sorry, I saw Deja's hand first. Sure. Let's say ooh, there is a way we can do so. That was the way I actually thought of automatically, but I wanted to break it down because I thought this way might be easier. But here's what we can do. Let's say car owners dot each. Instead of saying dot each, let's say we map to the owner dot cars dot count. So if we do this, let's say car owner dot average, what we get, so we have an array of car owner dot all. Well, who are the 2 car owners? Just me and Chine. We've mapped it to owner dot cars dot count. So we have an array of 2 owners. Now we have an array of 2 numbers, which is how many cars they own. And then what you could do, you could just say, let's see, Ruby, find average of an array. Calculate the mean from a Rubian array. Okay. Okay. Dot sum divided by dot size. So I am going to say, let's save this in an array called averages. So return so this way could be a lot easier. So averages dot sum divided by averages dot count. Or dot size. So dot count, dot size, and dot length, all synonymous because Ruby's just that nice to you. Car owner dot average 1.5. Okay.
Could you also have done that by just doing car.all.count to float divided by owner.all.count to float?
Yes, you could have. Okay. Let's run through the last 2 real quickly. So mechanic, car owners, junior. So every method has a type, name, and logic. This one I've highlighted over on the right, mechanic.carOwners. Is this an instance method or a class method? It's an instance method, and we're going to name it car owner names. Okay, let's just put in a binding.pry. See if we can call it. So if I want to call this instance method off from mechanic class, I'm going to have to get a mechanic. So I can say beza.car owner names, car owners names. I hit this pry, and how do I find a list of Beza's owners, or I'll call them customers, so Beza's customer's name? Is there a method where I can say, given Beza, how can I find just her customers, just her car owners? Is there a method I could possibly use, you guys think? So given an instance of the mechanic, given Beza, given self, we can say self.carOwners. This is going to give me a list of owners that Beza is servicing. Well, really, she's servicing their car. And then because the car is owned by an owner, she's servicing them. So I have an array of 2 car owners that Beza serves. How would I just collect their names? T, what do you think? Use .map. So the thing we're iterating over, so self.carOwners is an array of owners. And then what should I put in the block? What is it from the owner that I want to collect? So yes, the name. And what's the method we call to get that is just owner.name. So remember, this is a method that we created right here on line 2. This method.name, we can call it off any owner instance. And that will give me an array of customers' names. If I wanted to test this out, I could kill this and say Brett.carOwners names. Brett only serves Anne. Scale of 1 to 5, how are we feeling about this car owners names method? So car owners, let's do this. So Brett.carOwners gives us an array of what data type? Michael, I'll have you answer this as well. So given Beza.carOwners, given Beza.carOwners, returns an array of what, Michael? It's not hashes. This is an array of owner instances, car owner instances. That's what this is. So Beza.carOwner names, how are the 2 different? Michael? That's exactly it. So mechanic, we were supposed to create an instance method called car owners, get a list of car owners that go to this specific mechanic. But this method says get a list of names of all the car owners that go to this specific mechanic. Okay. Michael, Sebastian, and T, how are we feeling about car owner names?
So basically, this is what the map is what would transform the string over to an object.
Or the other way, it transforms the object into the string. Right, because owner is an object, and now we specify the transformation. Well, what do you want to transform it to? Well, I want to take this owner instance, call this .name method, and then whatever this .name method returns, that's the transformation. Exactly, that's why. Okay. Last one, car.findMechanic. Ooh, get a list of mechanics that have an expertise that matches the passed in car classification. I'm actually going to go through this one a little bit quickly. So every method has a type and a name and some logic. So type, this is a class method. So self, let's define self dot find mechanic. And it should take in a classification. So let's go ahead. I'm actually going to kill car owner because we don't need it anymore. So how I call this method on line 24 right here, I call car dot find mechanic, and let's find a mechanic that specializes in antique. Oops, I forgot to put in a binding.pry. Binding.pry. Let's go ahead, run this again. Okay, car.find mechanic. Let's pass in antique. Okay, so I can always look at self. Self is the car class, but I can always find all my cars, all my mechanics, and all of my owners. I want to get a list of mechanics that have an expertise that matches the passed in car classification. So if I want a list of mechanics, maybe first thing I should do is get all our mechanics. So mechanic dot at mechan, I cannot spell. Okay, now I want to see which one of these matches the passed in car classification, which in this case is this local variable classification. So how would I find all of the mechanics that have a specialty of antique? It would be mechanic.all. You start with a list of all your mechanics and you want to narrow it down. Only find me a list of mechanics that have this expertise. So what we're looking at is a dot select. And what we're iterating through is a mechanic. Let's put in a binding.pry. Oops, binding.pry. Whoops. Let's bring that terminal back. Come on. Okay. So I'm going to say car.find mechanic. Find me ones that specialize in antiques. And so the first mechanic is Beza. Does she specialize in antiques? Yes, and how I know that is I can look at classification, which is the passed in variable, and I can compare that to mechanic dot specialty. That is true. Let's type exit, which is going to bring us to the next mechanic. So what is mechanic now? Mechanic. This is Brett. Does Brett specialize in antique cars? No. Here's classification. If I compare that to Brett the mechanic's specialty, that's not true. So I can just check, is the classification antique equal to that mechanic's specialty? That's false. So this is the condition I can use in my select. So let's try this out. Car.find. Find me a list of mechanics that specialize in exotic cars. Found you Brett. Okay, let's try to find a list of mechanics that specialize in antique cars. You found Beza. What about a list of mechanics that specializes in sports cars? Junior, what do you think will happen now? Well, in this case, we're looking for sports. Are we going to find any mechanics that specialize in sports? Let's see. So we have a mechanic that specializes in antique and one that specializes in exotic cars. Nope. But given this information, so what would you expect? So what do you expect will be returned when I call this method? Let's see. So we get an empty array, and remember, select will always return some array. Maybe that array is empty, maybe it's not. Find will sometimes return nil. How do you guys feel about this method find mechanics on a scale of 1 to 5? Okay, Michael, you had some questions about it?
Yeah, the only thing I'm a little ambivalent about is when it takes in the parameter, how to go about it with defining def classification.
Yeah, so let's take a look. So how I called this method was I called it using car.findMechanic, and then I passed in antique. So this is the argument. It becomes the classification parameter. That's how you would test it. T, I think in our case, yes. So we wanted to match up the specialty of the mechanic to the classification of the car. That was in the instructions. T, I missed your hand. How are you on 1 to 5 for this method? Let's try it. What happens if I put it here and classification goes here? Does this still work? If I say car.findMe exotic. Yep, works all the same. Okay, so you guys are going to be doing your retake tomorrow morning. Can you guys hear me all right? So I want to let you know that it's going to be similar, but also typically a little bit different. We'll give you guys basically the full morning. It'll be just like your code challenge from last week. But the norm is that with code challenge retakes, we will have an instructor pop in from time to time to just kind of see how you're doing. It's supposed to help with test anxiety because we want you to be able to show us what you know. We don't want you to freeze up and like be super nervous. So the point of that is myself and Chine will pop in from time to time just to see how you're doing. Maybe if you're struggling, we'll kind of like ask you certain things to reframe the question, and we'll also answer any clarifying questions you have because we want to make sure like you're building out the methods you're supposed to be building and not building out a different method by accident. If you think that will make you more nervous and you would prefer not to have an instructor check in on you, and you would prefer only have instructors check in on you if you have questions, please let me know. You can let me know here or you can Slack me. But otherwise, just know that like myself or Chine, we might come in from time to time just to see how you're doing. Deja. Okay. Okay. What's up, Sebastian? Yep, you can tell me to screw off, yeah. I'm kidding. Yeah, I'm kidding. That's perfectly fine. It's supposed to be normal, and it's much. I promise you this. It's much less intimidating in an in-person program because we're just kind of in the room and we like proctor you guys and we like just check in on you, and it's weird in a remote setting, but yeah. What's up, Junior? So you guys, this was deployed as a practice challenge last night. It'll be in the very last section under additional practice, under additional practice object orientation, and then the very last learn lesson is object-oriented Ruby auto shop. Of course, Deja. So it would be very similar to this morning's whiteboarding question. So you would need to somehow keep track of how often does this model come up? Just like how often does the number 5 come up? Yep. So it'd be easiest to generate that hash, and then from there, return whatever.